Alright, I'm going to explain to you what a horizon is on a ball or a globe or a sphere. So you can see we have here your basic water-covered sphere. I've got some hills, and I've got some sea creatures. What else do we got? Ooh, so that's what's in there. Okay, never mind that. So picture yourself up on this hill, and you might sort of think, well, if you're looking down at the horizon, that you would actually be looking, let's say you're 50 feet high, you might think that you're actually looking down to sea level, because this is sea level at your feet. So I've drawn a line out here. So where you're located, this is sea level and straight out, and here's your location here, 50 feet up on this hill. This is obviously not to scale, and straight out at eye level is out like this. So you might imagine if you're looking down at the ocean's surface, you would simply be looking down the 50 feet and out the distance. And on a flat earth or a plane, that would be true. On a sphere, however, that's not true, because in this distance here, it's also curved down, so it's actually lower. So you're actually looking not only down to what ground level is at your location, but then you're looking even farther down to below ground level. And so you can see this is basically just kind of a mirror of this. However high this is here to your ground level, your sea level, is the same. It's just a mirror of what it would be like if somebody was over here at the same height looking at you. And so this explains why you have more vertical drop than you would expect. So if you're 50 feet above sea level at your location and you're looking at the horizon, it's going to be roughly 50 feet lower than sea level as compared to your location, because the sea level is lower. So you're actually looking 50 feet below your local sea level, or 100 feet below your eye level. Now, you might have noticed that the angle of these, actually, if I were to draw a straight line up here, that would not be the full 50 feet, and you're correct. And if this were the ratio of the hill you're on compared to the size of the Earth, then that would be correct. But I'm just showing it exaggerated sizes so you can understand. If it were actually only 50 feet, this curve of the Earth would be so gradual that these two lines would still be quite parallel, and so the distance lost due to the angle would be negligible, because the angle would be negligible. But so this is why when we say that you're standing there looking at the horizon, and the horizon is underneath your local sea level, that's why, because the line of sight is a path that cuts through the center of your local sea level right here, and by definition these two lengths will be the same. And so I hope that explains it.